Welcome back everyone to a Khan Academy tutorial. Today we're going to be talking about multiplying and dividing powers, integer exponents. So the first prompt is simplify. Rewrite the expression in the form a to the n. Well, we should recognize this as exponent form, where 8 is our base and n is our exponent. Now exponents is or power. Now exponents are all about repeat multiplication, so it will tell you how many times the power indicates how many times you're going to multiply 8 times itself. So here, in our first example, kind of have a tough one, and I would advise you to watch the previous videos when we talk about multiplying like bases with exponents. But we should recognize that we have 8 and 8 are like bases. Okay, these bases are equal. So if that is the case, and we have multiplication, and that's what's going on here is we have multiplication, what we're going to do is we're going to take the powers. 3 and negative 8, those are the powers, and we are going to add exponents. Anytime you have multiplication of like bases, you will add the exponents. So what we're going to do is we're just going to say this whole expression is equal to 8 to the negative 8 plus 3, because we're adding those two exponents. Well, what does that equal? It equals 8 to the negative 5th power, where 8 is our base still, and then our power now is to the negative 5th power. So let's go ahead. Well, before I show that, let me demonstrate another way of looking at it. Because it's a negative 8, that's the same thing as 1 over 8 to the 8th power. That's the same thing as 8 to the negative 8 times 8 to the 3rd. That'd be in the top. So we rewrite it. It would be 8 to the 3rd over 8 to the 8th. What happens? Well, we would have 3 of those 8s get canceled away, with the bigger number, leaving 5. That's 1 over 8 to the 5th, and that's another way to write a to the negative 5th power. So just to give it full circle what the negative exponents mean, that's why our answer is definitely correct. So we're going to write 8 to the negative 5th power here. 8, whoops, let's go back. 8 to the negative 5 power. Check it. There we go. Doing great. Same thing here. We have same bases, x and x. Then we have the exponents 2 and negative 12. We're going to add them, and we get x to the negative 10. So let's go ahead and write x to the negative 10 power. Check it. Good to go. Okay, now rewrite the expression in the form 5 to the n, so exponent form. Well, it's kind of like it was before. We have 5 to the 10th, 5 to the 12th. Two ways to go about this. The way I like to do is I just like to think, okay, if I have 10 5s being multiplied in the top, they're going to cancel with 10 in the bottom, leaving 2. So they can't be 0 on the top. It's going to be 1 over 5 squared. Well, why is that the case? Well, let me go ahead quickly and write 5 times 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 5. That's 5 to the 10th power. And that is all divided by, here we go, 6. Hold on, that's in green, this is in pink. So now we have 12 5s being multiplied together. This is expanded form, in case you're wondering. I would not advise doing this each time. It's very time consuming and it's really a waste of time, but it's good to demonstrate. So what I'm going to do is you could rewrite each one as a fraction. Anything you see in the top, you can cancel with the bottom. So as I do this, you see I run out of pink faster than I'm running out of green, and you'll see that I'm left with 2 in the bottom. Well, it goes to 1 in the top over 5 squared in the bottom. The easier way to do it is probably just thinking, okay, 5 to the 10th divided by 5 to the 12th. Well, I could rewrite this as 5 to the 10th divided by 5 to the 12th, and it's just the opposite. Before, when it was multiplication of like bases, we added the exponents, right? That's what we did, added. But now it's divide, so we do the exact opposite. We are going to subtract the exponents. The one on the left subtracting the one on the right. So it becomes 5 to the 10 minus 12 power, which of course equals 5 to the negative 2. Okay, that's the same thing. That's equivalent to 1 over 5 squared. So let's go ahead and write 5 to the negative 2 power, negative 2, and check it. Okay, let's do a few more. Here we have the same thing. We have x to the 6th divided by, or a fraction, x to the 8th. We're going to subtract exponents, so we should get x to the negative 2 power. We're going to check it. Doing great. Here we have multiplication, like bases. We're going to add exponents, so it's going to be 5 to the negative 18 power. Whoops, I don't know what happened there. Let me delete, and there we go. Negative 8 plus a negative 10 is, of course, negative 18. Negative 18. Check it. Doing great. Might as well finish. Okay, negative 6, it's multiplication. Like bases, we're going to add exponents. So it's going to become, let me do my exponent, b to the 5th power. Check it. Doing great. This is a tricky one. So let's make sure we take our time on this. So we have 5 to the negative 5th divided by 5 to the 8th. Well, we know we subtract exponents. So we have negative 5 minus 8. What does that equal? Negative 5 minus 8. That gives us negative 13. Okay, so that's going to be our answer. Another way to think about this problem is anytime you have a negative exponent, you could rewrite it as a positive exponent by moving it to the other side of a fraction. So this becomes 1 over, because it's got to be, you can't just vacate the numerator and denominator without leaving a 1, 5 to the 8th times 5 to the 5th. It became positive because we moved it. And of course that is 1 over 5 to the 13th, which is the same as 5 to the negative 13th power. So we're going to write it as 5 to the negative 13 power. Check it. Well, we just went through 7 problems. I hope you guys found this helpful, and I'll see you next time on West Explains Best.